Hello everyone. Today we are going to discuss about certain topics which has historical importance since Queen Victoria's childbirth to World War II during the treatment of malaria and typhus. Do you know that DDT was used for the treatment of malaria and typhus during the World War II? Do you know that chloroform was used during the childbirth of Queen Victoria? Though we know the detrimental effects, or maybe we'll discover the detrimental effects of these compounds in our next topic, polyhalogen compounds. So our topic today is polyhalogen compounds, and we have these set of compounds to discuss. These compounds, 6 compounds to discuss. Number 1 is methylene chloride. What you are seeing, these all are the common names of these compounds. They are the common names of the compounds. So methylene chloride number 1, its formula is methylene system 1 carbon atom. So methylene chloride means CH2Cl2. This is the chemical formula of methylene chloride number 1. And what will be its IUPAC name then? As per IUPAC, methylene chloride has a name like this is carbon number 1 only. It's only 1 carbon atom. So we will say dichloromethane. Dichloromethane. This is the name, IUPAC name. And this is your structure. Next comes, how are we supposed to prepare methylene chloride industrially? It is prepared by the direct chlorination of methane. So methane is CH4 and direct chlorination means 2 moles of Cl2 in presence of Hnu. It is a free radical substitution reaction where the H for 1 mole of Cl2 it will be substitution of 1H. For 2 moles of Cl2, it will be substitution of 2H. So CH2Cl2 plus 2HCl. This is the preparation. What is the use? So this is your preparation. And now what is the use of this compound methylene chloride? It is actually used as a solvent. It's an organic solvent used in pharmaceutical and food industry. Solvent used in pharmaceuticals and food industry. Okay, so this is what information you have regarding the compound methylene chloride. So this we are done with. Next comes chloroform. So chloroform, now methylene chloride, one thing I need to tell you that it has some adverse effects as well. If it comes directly to your skin contact, then it may cause burning sensation. It may give you rashes. It may give you redness to your skin. If it comes to your eyes, it may damage, even burn the cornea. So it has adverse effects as well. So after this, number 2 is chloroform. So number 2, chloroform CHCl3. This is the molecular formula, how you write chloroform. Chloroform has the IUPAC name trichloromethane. Some may write 111 trichloromethane. That is okay, but when you have only 1 carbon atom, I think I have mentioned in my previous videos also that when there is 1 carbon atom, you did not write 111. You can directly write trichloromethane. That is chloroform. Now, in the beginning of this session, I told you regarding Queen Victoria's childbirth, the chemical that has been used, that is chloroform that has been used. But nowadays, is it used? No, it is not used nowadays because of its detrimental effects. What detrimental effects? Chloroform gets readily oxidized to a poisonous gas. So here is the reaction of oxidation of chloroform, and it is assisted in sunlight. it is assisted in sunlight. It forms 2 moles of COCl2, we can see, plus 2 moles of HCl. This compound COCl2 is known as phosgene and it has adverse effect. It is toxic gas. It's toxic in nature. So the question arises, if it is so, if chloroform undergoes oxidation in presence of sunlight, how is it stored? So storage of chloroform is very, very important to know that it is stored in closed dark bottles, okay, or very, very dark colored bottles. Now, where the chloroform is filled to the brim, completely filled, closed dark colored bottles that are completely filled in order to avoid air, in order to avoid oxidation that can take place. At times 1% ethanol is also added to it. Now, why is this 1% ethanol added to it? Because if phosgene is at all produced, this phosgene will react with the ethanol. COCl2 is phosgene. It reacts with the ethanol C2H5OH to produce a non-toxic compound which is known as diethyl carbonate. This is your OET. When I write ET, it stands for C2H5. ET means ETOH is ethanol. So ET is C2H5 group. So this is known as diethyl carbonate plus 2 moles of HCl. So chloroform is having a name, the IUPAC name, that is trichloromethane. This is how it reacts with oxygen. It's highly reactive. It undergoes oxidation reaction in presence of sunlight, and it gives phosgene, which is toxic in nature. And it is stored in closed dark colored bottles. At times 1% ethanol is also added. Why it is added? This is the reaction. So after this, again let me tell you, chloroform, on account of this production of phosgene getting oxidized and all these things, nowadays it is not used for anesthetic purposes. So number 3, we know iodoform, I told you. So iodoform is actually a haloform. Now what is haloform? Haloform is CHX3. When X is equal to I, then it forms iodoform. So CHI3 is iodoform. Again, it has IUPAC name like chloroform. It has IUPAC name triiodomethane. Now, it is prepared by the haloform reaction only. It used to be used as an antiseptic. It was used earlier as an antiseptic. But this iodoform, when it was used as an antiseptic, the antiseptic properties were not due to the iodoform, but due to the liberation of free iodine. So this is one of the question of 1 mark which is asked, that you justify the antiseptic behavior of iodoform, or why does it show antiseptic behavior? The answer will be due to the liberation of free iodine. It shows antiseptic behavior. And remember that it is not because of the iodoform. I mean, you cannot say iodoform is an antiseptic because of its own property. No, it liberates iodine, and that's why it is acting as an antiseptic. Okay. Now it has an obnoxious smell also, objectionable smell, that is known as obnoxious. This is prepared, iodoform is prepared, and this preparation, this reaction is quite important, haloform reaction, to know, because when you will do carbonyl, when you will do alcohols, you will come to know. It is prepared by the action of iodine and alkali on alcohols on carbonyls. So how it is prepared? So it is prepared by haloform reaction, and this can also be told as iodoform reaction. How? Let us see. See, alcohols containing, not all alcohols, alcohols containing CH3CHOH group, okay, and carbonyl compounds that contain, carbonyls containing CH3CO group, CH3C double bonded O group. This actually is known as a ketomethyl group. These types of compounds, they respond to haloform test. Haloform reaction is a reaction where alcohols containing CH3CHOH group and carbonyls containing ketomethyl group, they react with I2 and NaOH. So let us see, it reacts with I2 and NaOH to produce in situ sodium hypoiodide. So let us see, 2 moles of NaOH reacts with I2 to form NaI plus NaOI. This is responsible for the reaction, NaOI, and it forms H2O. So it is in situ generation of sodium hypoiodide. Sodium hypoiodide. Okay. So what type of compounds I said? Alcohols containing CH3OH group. When you see, actually, if any alcohol contains CH3CHOH group, it gives haloform, and carbonyls containing CH3C double bonded O ketomethyl group or methyl keto group, both are used. Why they respond, these types of alcohols? Because actually they can get oxidized. Oxidation is removal of H2. You can remove these two H2 and you can say that this alcohol is getting oxidized to this carbonyl compound, and so they respond to this iodoform test. So what is the reaction? Let us take an example of this alcohol, say CH3CH2OH. The name is ethanol. It reacts with 4 moles of I2, 6 moles of NaOH, and in the previous reaction only we have seen, I2 and NaOH reacts to produce NaOI in situ. So what will happen? It will react to give CHI3. It's a yellow PPT, yellow colored PPT, precipitate of iodoform. Along with this, we will obtain HCOONA plus 5 moles of NaI plus 5 moles of H2O. So if you take an alcohol containing n number of carbon atoms, here it is straight away 2 carbon atom. So if you take n number of carbon atom, see in the formation of the iodoform 1 carbon atom is involved. So the acid which you will get, this one, your salt, sodium salt of the acid that you will get, it should contain n-1 number of carbon atoms. So you have to write the reaction accordingly. You should learn to observe the reaction. So after this, I can give you an example of a carbonyl compound containing ketomethyl group, say CH3C double bonded O. This side I can give H, then it will become aldehyde. If I give CH3, it's a ketone, and the name of the ketone is acetone. So name of the ketone is acetone. Acetone, when reacts with this NaOI, acetone reacting with NaOI, or the same way I can say I2 and NaOH, 3 moles of I2, 4 moles of NaOH, it gives CHI3 iodoform, and it gives, see, one carbon atom less I said, so here there is 1, 2, 3. In iodoform there is only involvement of one carbon atom, so left over 2, which forms CH3COONA plus 3 moles of NaI plus 3 moles of H2O. Now this iodoform test, producing yellow precipitate of iodoform, this is used as a distinguishing test for compounds having this type of functional group, this type of linkages. Like if I say, how can you distinguish by chemical test? You can distinguish by chemical test methanol and ethanol. So you can use this where ethanol will respond and will give yellow PPT and methanol will not give. I can say distinguish by chemical test formaldehyde, HCHO is formaldehyde, and acetaldehyde. The same thing you will do, formaldehyde and acetaldehyde. Acetaldehyde is what? Acetaldehyde is CH3CHO. So it contains ketomethyl group, it will respond. Now we have CCl4 to discuss. CCl4 is carbon tetrachloride. Its IUPAC name is tetrachloromethane and it is prepared from methane by this method. CH4 by free radical halogenation, 4 moles of chlorination, free radical, and it is also prepared from carbon disulfide in this method. Now it is used as an organic solvent. We have seen in bromination, bromine in CCl4 is being used for bromination over unsaturated compounds. Next we have freons. Freons are chlorofluorocarbon compounds, carbon compounds containing fluorine and chlorine. One such renowned is Freon 12, that is CCl2F2, which has wide use in industries. But freons are responsible for ozone depletion, and so for that reason they are now banned. So now, how to prepare freon from carbon tetrachloride? There is one reaction where we can see that carbon tetrachloride reacts with antimony fluoride, SbF3. Now, in presence of antimony chloride and heat, and it forms CCl2F2. This is your Freon 12. This is your Freon 12 plus 2 moles of SbCl3. So this is how Freon 12 is prepared. Now next our discussion will go to the factor which we have seen that it was used during World War II in order to restrict the spread of malaria and the lice that carry typhus. Okay, and that's what? That is DDT. That is DDT. Now, what is the full form of DDT? The IUPAC name of DDT. What is the structure of DDT? All these things we need to do. So, it is P dash dichloro. First D stands for dichloro. The next D stands for diphenyl and dichloro, diphenyl and trichloro. T stands for tri, so trichloroethane, that is DDT, trichloroethane. So D, D, T, dichloro, diphenyl, trichloroethane. Now if you need to draw the structure from this name, we need to focus on the parent ethane. Ethane means 2 carbon atom, so this is eth system. Now dichloro, P dashed, dichlorodiphenyl, trichloroethane. Now trichloro actually means 3 Cl atoms in 1 carbon, and the other one is dichlorodiphenyl. Mane, it is having a phenyl ring where, see this linkage, if this is P, if this is P, then the P dash will be the other side. So PP dash, that is the reason. Chloro. Here again a ring, aromatic ring, para position, and then here there is Cl. So it is P, P dash, and the other one is H. Okay, so if I number it, how will it go? Numbering starts from here, goes to here. So it will be what? 1, 1, 1, trichloro, 2, 2, within bracket 4, chlorophenyl, ethane. Ethane is parent. So ethane. 1, 1, 1, trichloro, 2, 2, 4, chlorophenyl, ethane. Now, this type of linkages, where you have two linkages like this, for this we can write a bis over here. Okay, generally we use it for chelating ligands, but here it is bis. It's a big structure. So bis means two. Two such structures are there, 4 chlorophenyl ethane. Okay. Now next, DDT has detrimental effect to the environment. It's a threat to the environment. The use of DDT is actually a threat. We have been seeing the use of DDT as an insecticide. It has been widely used as an insecticide, true. But it is a threat to the society or to the environment. Why? Because if people use DDT, this DDT goes to the water bodies. The problem with it is its chemical stability. DDT is highly stable. The problem is its chemical stability and fat solubility. These two are the real problem. On account of this, what happens? They are not metabolized by the animals if they take it, especially the aquatic species. In case they take it, they consume DDT. Then in that case, what will happen? And how can they get it from the water bodies? By the contamination. So since DDT is chemically stable, it will not get metabolized easily also. And due to its fat solubility, it can easily enter the bodies, animal bodies. Okay, so this is why DDT is banned. If my video was useful and was helpful to you, do like my video and do join and come to the comment section in order to tell me what was helpful, what I should do in order to assist you more. Thank you all of you. Bye.